Alright guys, so this is in 6.1, but it's a preview of what we're going to do in 6.2, which I'll send out a video tomorrow. And so you're going to get a differential like this one here, y prime plus y, and they want you to find a power series. So here's our power series. So just like when you made y equal to e to the m x, or you made y equal to x to the m, now we're going to make it into a power series and then solve the differential by finding a power series that works. Okay, so what you want to do first is calculate the derivative. So if you think about taking the derivative here, right, c of n is a constant, the n comes down, and then you have x to the n minus 1. Okay, what I'm going to do is plug in, right, these two, the y and the y prime, into our differential. So what it'll look like is we have plus y and then we have it equal to 0. Okay, so once you do that, all right, now we go back to my last video where I want to try to get this into one, into one series. So again, when you're looking at that, the easiest way is to make your k value equal to the exponent. So this one's easy, k is equal to n is easy. Here we're going to have n equal to k plus 1. Okay, and then try to see, like, if you plugged in, so let's go back. So if you plug in 0 here for n, well, that wouldn't help us. That would give us a -1. We don't want to have a negative there. So what I want to do is plug in 0 into that first series so that I could start at 1. Okay, this is alright because here we have k. This one's alright because k is equal to 0. So as long as I could get this to match when I plug in, if you guys notice, I'm plugging in this here and that's giving me a -1. I want it to be a 0. So what I'm going to do is just plug in 0 everywhere that I see an n. Okay, and if you do that, that works out, pretty nicely, because you're just going to get a 0 anyway, right? Because 0 times n will just give you 0. So we're really going to have this where now I could put n equals 1 to an infinity n c of n x to the n minus 1. Okay, and then plus, this is just going to stay exactly the same. All right, now if you plug in, right, we're going to use this substitution I have up here, right? So now if I plug in the 1, I get to 0, which that's a good thing. So here I could have in k is going to be starting at 0 because I'm plugging in now the 1 into that n, and that gives me 0. Okay, everywhere else, right, we're going to use this for anywhere we see an n. So it's going to look like c sub k plus 1 times the k plus 1 and then x to the k. Now it should always work out to be x to the k. This one you're just changing everything because it's the same. And now we could make this into one series where k starts at 0. We're going to have c sub k plus 1 times k plus 1. I'm going to factor out that x sub k, and then we have plus c sub k, and then the whole thing x sub k equals 0. Okay, so now this is what we did last time. So once we're down to this step, okay, we want to solve for k, or how could I say this? Yeah, solve for k. Now, k is inside here, right? So as if we could solve this inside portion and set that to 0, then we'll be able to find what x of k is going to be. So that's the way this is going to look. So you're going to say c sub k plus 1 times k plus 1 plus c sub k equals 0. And then we're going to solve this, okay? Now, what you should always do is always solve for the greater constant. So c sub k plus 1 is what I want to solve for. So I'm going to get c sub k plus 1 equals c sub k over k plus 1. Okay? And now go back up to see where we start. So because our series starts at 0, I'm going to start my k values at 0. So I'm going to just keep plugging in 0, 1, 2, 3, and so on. When I do that, so let's look. What is c sub 0, right? If we plug that in, I'm going to get negative, if I plug in 0, so everywhere you see a k, okay, we're going to plug in 0. So I'll have c sub 1 equals negative c sub 0 over 0 plus 1, which is going to give me negative c sub 0. All right, if I plug in c sub 1 now, so I'm going, this was when k was 0, this is when k is 1. I'll get c sub 2 equals negative c sub 1 over 2 now. Okay, so that's going to give me negative 1/2 c sub 1, but we already know c sub 1, okay? C sub 1 is equal to negative c sub 0, so this winds up to be a positive 1/2 c sub 0. And then you just repeat this process. Okay, so negative c sub 2 over, and this one is going to be 3, right? So here we're going to get a negative 1/6 c sub 0, and so on. So I could even do one more to show you. K is equal to 3. We're going to get a negative c sub 3 over 4. That's going to give me 1 over 24 c sub 0. Okay, once you're down to this step, right, what you want to try to do is think of it this way, like you just found values for y, where c sub 0 is just a constant, right? So what we could do is put this into a power series, meaning, like, let's go back to what a power series looks like, okay? So if you have your power series that we started with, 0 to infinity, c sub n, x to the n, right? This is going to give me c sub 0 plus c sub 1 x plus c sub 2 x squared plus c sub 3 x cubed plus c sub 4 x to the 4th and so on. All right, so what I'm going to do is, because we know all of these values, c sub 1, 2, 3, 4, we could write them this way. We now have c sub 0 is going to stay. C sub 1 is going to be negative c sub 0 x plus 1/2 c sub 0 minus 1, oh, I forgot my x squared plus, which will be a minus 1/6 c sub 0 x cubed, and then a plus 1/24 c sub 0 x to the 4th, and then whoa, sorry. And then you have the dot, right? Okay. Now here, let's factor out a c sub 0, right? So here, if you factor out, you get 1 minus x plus x plus 1/2 x squared minus 1/6 x cubed plus 1/24 x to the fourth, and then plus dot dot dot, and it continues on. Okay? So basically what we did was we solved, and if you think of, the way we always solve, we have like your c sub 1 y1 plus c sub 2 y2, and then so on, right? But in this situation, you could see our y1 is just going to be here because we only have this one constant. So my y, or my solution, is going to be 1 minus x plus 1/2 x squared minus 1/6 x cubed plus 1/24 x to the fourth. That could be my y1, and y2 could be 0. Again, we could also write it in sigma notation, where you have c sub 0 as the constant outside, n equals 0 to infinity, and then you would have a -1 to the k, or to the n. Doesn't really matter which one you pick, but just stay consistent. N over n times x to the n. So you could have, different ways of writing these. So this is just a preview of it. Tomorrow, I'll probably send out a video on the more complicated ones in 6.2. All right.